Welcome to Engineering Knowledge. Today we will discuss what is convolution, what is difference between convolution and cross correlation, and difference between linear convolution and circular convolution, and zero padding and effect of zero padding. That is, first topic is what is convolution. It is a mathematical operation on two functions that produce a third function expressing how the shape of one is modified by the other. That is the mathematical operation of two functions. We use generally x and h that produce a third function y expressing how the shape of one is modified by the other. That is, x or h is modified by h or x. Okay, and cross correlation, it is the measure of similarity of two functions. That is, x or h, say similarity between two functions or signals. These functions are used, these mathematical functions operations are used in many fields such as probability, statistics, signal processing, image processing, but we are more concerned with signal processing here. So in linear systems, convolution is used to describe the relationship between three signals of interest. In linear systems, that is, three signals of interest are input, system and output, x, h and y. It is a representation of convolution in continuous time domain, ft convolution ht, represented using a star sign, ft star ht convolution for f tau g tau t minus tau d tau. That is first function, second function. Similarly, cross correlation is represented using c f tau g tau plus t and using for the whole period. Only difference is that second function. The second function in convolution is flipped or folded and then shifted, whereas in cross correlation function, second function is only shifted, not flipped or folded. Okay, this is the basic difference between convolution and cross correlation. Before going to this topic, first we will study the difference between convolution, correlation and cross correlation using these set of paper sets. Suppose it is a signal, we have two signals suppose, and now we have to find the convolution of these two signals. It is, both signals are symmetry around the origin. So in convolution, what will we do? We will first invert the function, fold the function, okay, fold the function and then place in continuation to here, and then multiply the signal with this signal. Okay, multiply the signal, that is in continuous time domain, multiplying the signal, moving the signal across this, and we will have the maximum value of convolution here. Then the value will decrease it down because it is, you can see the overlapping is becoming less, and now overlapping is 0. The function will become 0. So this is what convolution. Okay, moving the signal from right to left. Oh, then if we have to done the cross correlation of the signal, the only factor is that we will not fold the signal. We will just place the value as it is and do the same operation of multiplication. Do the same operation of multiplication, and you can see that the output will be same. The output, that is the same overlapping, the same signal is traveling, and output will be same. So if the signals are symmetric, then cross correlation and convolution operation are same, are resulting the same value, because after folding the value, folding the sequence, it becomes the same signal. Okay, but suppose we have now another signal, that is this signal. Suppose now this is not a symmetric signal, so if we fold this signal, it becomes like this, and we will put here after folding, and then after folding we will put here, and then we will multiply the values, shift this function and multiply the value, shift the function, multiply, maximum value we will achieve here, then overlapping will become less and less, and we will have the value 0 when there is no overlapping. So this is what convolution. But if it was correlation, cross correlation, then the signal was initially the signal was this one, so we just put the signal A here and do the multiplication. Now the value will be changed, because you can see that value will be changed. Here it is the maximum overlapping, again overlapping decrease, and suddenly overlapping becomes 0. So the signal is That is what cross correlation. If we will put the signal as it is, then it is cross correlation. If we invert the signal and then put it and multiply, this is convolution. Okay. Now, what is autocorrelation? Autocorrelation means if this signal is this one, then it will be a symmetric signal, and again the same, because inversion of this signal will be the same. Okay, inversion of the signal will be same. You can invert the signal, just put here and put here, just rotate, flip the signal, just flip the signal. Okay. Now, if both the signals are same, that is what autocorrelation. Definition of autocorrelation says, if both the signals are same, that is similarity index between itself, then it is known as autocorrelation function. The signal itself, autocorrelation function, same signal is here. Now one signal will move and one will be constant, same, stable, and then we will move and multiply, and it will be maximum when they are completely overlapped. That is why autocorrelation function is always maximum at zero value, center value. Then the function will again move on, shifted towards its right, and the overlapping will become less and less, and finally this is what autocorrelation function. So these sort of paperwork can describe the value of autocorrelation function, correlation, and convolution function. Okay, these three are the using these three signals. You can make your own signal and find out the if this all the practice is done in continuous time domain, then it is continuous time domain, then we should have to be integrate, and this is in continuous time domain. If this all practice is to be done in discrete time domain, that is in samples, if we do the sampling of these signals, and suppose we have done then 1000 sample of this and 1000 sample of this, and then sample will be folded and multiplied, then this is in discrete time domain. Okay, it doesn't have that any difference, because it is continuous time. It is when it is continuous time we use integration, when it is discrete time we use summation. Okay. So filtering action in digital signal processing is equivalent to convolution operation. We find that when we use the filtering term in DSP, it is the same effect as that of convolution operation in mathematics. So for linear time invariant systems, which is characterized by either impulse response Hn, suppose a system, linear time invariant system, Xn is the input, impulse response is Hn, output will be Yn, which is convolution of Xn in convolution Hn. And what is this Hn? Hn is what? When system has the impulse input, then what will be the output? The response of the system for any impulse input. This is known as impulse response of the system. The response of the system when impulse is given as an input to the system. Okay, Hn is what? Impulse, then impulse response. Okay, for the linear filtering action, we use this terminology very fine, that linear convolution operation. And linear convolution operation is shown by Yn equal to xk, Hn minus k, summation, that is k varies from minus infinite to infinite if it is discrete. And in the theory of discrete Fourier transform DFT, we use the term circular convolution, periodic sum, because of periodicity property of DFT. And this circular convolution is represented using this formula. The only difference is now summation varies from 0 to n minus 1 for that period only, and now the second function is the modulo n, because after n times it will be same, it will repeat itself. That is why it is modulo n. And capital N is the value of fundamental period of that DFT, and n, small n, varies from 0 to n minus 1. That is, capital N are the number of samples. Okay, small n is the instantaneous sampling. It is represented using Xn, capital N, circle, Hn, or convolution symbol surrounded by a circle, that is Hn. Both are the representation for circular convolution. Now we will study some examples of both linear convolution and circular convolution first. Suppose we have a sequence 1, 2, 3, 4 and second sequence 1, 2, 1, minus 1, that we call it X input, H impulse response. Okay, and then length of Xn is 4. Say we will generally use length of Xn as L, where length of Hn, here it is 1, 2, 3, 4 again, but say it is N. L for X length of input, M for length of system impulse response. So After doing linear convolution, linear filtering action, that is linear convolution or linear filtering action, we must have the length of new sequence, which is L plus M minus 1, 7. 7 is the length. When this X sequence will pass through this system having this impulse response, then the output must have 7 samples. The steps to find linear convolution are, we know that first we have to fold the function, then we have to shift and multiply after each step. Okay, so we will see. Suppose we have the sequence, previous sequence 1, 2, 3, 4, 1, 2, 3, 1 value is the sequence at having position 0, 1, 2, 3. These are the positions, and the Hn is given as 1, 2, 1, minus 1 in the last example. Now we will first plot the signals on the graph and then we will fold the sequence. Folding sequence is just inverting the sequence. It means plus value will become minus and minus value will become plus. So 0 will be as it is, and now this value will become here and this minus value will become here. 2 at the position 2 value will go to minus 2, at position 1 value will go to minus 1, reverse minus 1 position will go to 1. So just flipping, folding the signal. So it becomes now minus 1, 1, 2, 1, minus 1, 1, 2, 1. Just read the value from backward. Okay, and this is the folded sequence. Now what we'll have to do, shift the sequence, shift the sequence. Further we will shift 1 shift positive direction, 2 shift, 2 positive, 3 positive, 4 positive and 5 positive. We simply shifting the sequence in positive direction to finding the value at this value. Positive value. Suppose now it is the formula of yn. First value we will calculate using for n equal to 0, y equal to 0, put the n equal to 0 everywhere. It becomes xk, h minus k. It means sequence xk and sequence h minus k will be multiplied together. Multiplying is very easy. Just put the sequence and overlap each other with the center aligned so that it is overlapping shown here. That 0, 1, 2, 3, the blue values are for sequence H and green value are for sequence X, and these are shown that 0 value is overlapped with 1, its 1 value and its 2 value is multiplied and overlapped here. Further at one position it has 2 value and it has 1 value. All other values are isolated, individual values. Only 2 values are overlapped when we put the signal h minus k over the xk or xn. Okay, and then we will multiply the values. 1 will be multiplied with nothing becomes 0, 2 minus 1 multiplied with nothing, then 3 multiplied with nothing, 1 multiplied with nothing. Only 2 multiplied with 1 is non-zero value, 2 is multiplied with 1 non-zero value. So 2 into 1 plus 2 into 1 becomes 4. 2 into 1 plus 2 into 1, 4. So this is the methodology to calculate the convolution. Next value, that is y1, it is positive value, so we will move the h minus k function towards positive side. Okay, if we move this function towards negative side, then we can calculate y minus 1. If we move at the first step towards negative side, then we can calculate y minus 1. We can move further in negative side, we can calculate y minus 2 and so on. So where you move the h minus k function, you can have the value of y at that particular step or instant. Okay, single movement y minus 1, double movement y minus 2, triple movement y minus 3 and so on. Similarly in forward direction, single movement y1, double movement y2, third movement y3, y4, y5. So next value is y1, xk, h and 1 minus k, xk, these two values must be overlapped, and you can see the overlapping, that is 0 is overlapped on 0, that is 1 multiplied with 1, plus 1 is multiplied with 1, overlapped with 2 is multiplied with 2, here 2 into 2, 4. Now second position is overlapped with second position of this one, that is 1 multiplied with 3, so it becomes 8. 1 plus 4 plus 3 becomes 8. So this is the next value. Further we will shift the function by 2, that is position 2. You can see that this function is now shifting because 0 is now here, now 0 is here, now 0 is here. 0 reference is 0. Along the 0 we are shifting the function towards right. Further we can calculate y1, y2, y3 and so on, and after putting this all the value in a sequence, we have this final sequence. That is, this is the center value, 0 value, minus 1, minus 2, minus 3, 1, 2, 3, 4, 5, 6, 7. These are the values. Or we'll all know that further value will become 0 because now there will be no overlapping. So instead of doing minus infinite to infinite, we will do some values from where we will have the 0 and at last we will have the 0. Okay. Now finding the values, the only non-zero values are 1, 2, 3, 4, 5, 6, 7. 7 non-zero values. It means length of this sequence is 7, which is true as per the last calculation that x has the length L equal to 4, h has the length M equal to 4. The length of convolution sequence will be L plus M minus 1. 4 plus 4 minus 1, 7. So 7 we have calculated the value. It is equal to 7. This is the process that first we have any sequence will be retained same and another sequence will be folded and then shifted, multiplied, folded once, shifted and multiplied, shifted and multiplied, shifted and multiplied, and so on. This is the methodology of linear convolution. Now how to find circular convolution? It is again it's the same steps but now in a circular fashion. That is, suppose xn is given 2, 1, 2, 1 and hn is given 1, 2, 3, 4 suppose. Now we have to find the circular convolution. The formula is this xk hn minus k modulo n. K varies from 0 to n minus 1, and here capital N is 4 because all the bits L is equal to M is equal to L is equal to M equal to 4. So capital N is equal to 4. So summation becomes k equal to 0 to 3 xk h n minus k modulo 4. Okay. Now after summation, if n equal to 0, first position. Okay. First we will do what we will plot the function sequence on a circle. That's why it is called circular convolution. And we plot the sequence circle and circles. If we plot the sequence in anti-clockwise direction, that is forward direction. If you plot the sequence clockwise, okay, then it is reverse position. So first we will plot the sequence anti-clockwise, that is in forward position 2, 1, 2, 1. That is sequence X. Positions are 0, 1, 2, 3. And for the sequence H is 1, 2, 3, 4 in forward direction. Positions are 0, 1, 2, 3. Okay. And so we will plot the functions on the circle, and it is 2, 1, 2, 1 is the forward direction. We will plot 1, 2, 3, 4 again. Now first property is again the same, folding. We will fold the signal H, and folding in circular convolution is nothing but the plotting of signal in opposite direction. Just plot the signal in opposite direction. 1, 2, 3, 4. Opposite direction. It is clockwise and now it is anti-clockwise direction. And it is H minus K. And the second step is shifting. Shifting is again the forward direction. Position, forward position, 1 shift, 2 shift, 3 shift. And you know, when it is a 4 shift, then it becomes again the same signal. That is what the property of modulo n property. Okay, you can check out that if you shift 1, 1 is here, second shift 1 is here, third shift 1 is here, fourth shift 1 is again here. So after 4 shift, it becomes the same signal. So in circular convolution, we shift only n minus 1 times. Okay, h minus k, h1 minus k, 2 minus k, 3 minus k. Now the step is same, that first we will multiply x with h minus k. X is multiplied with x minus k, that is for n equal to 0, xk, h minus k. And it is the same easy method. First plot the circle 1 and plot the circle 2 overlapped each other with the positions overlapped. 0, 1, 2, 3 positions should be overlapped, aligned, and then multiply the coefficient, multiply the numbers. That is first, that is 2, 1, 2, 1 for blue is in X, and 1, 4, 3, 2 in green is for H, and multiplying the values 2 into 1, 1 into 4, 3 into 2, 1 into 2, and multiplying the signals and adding all the values will result 14. Now the second value, shift the signal H1 minus K and again overlap these two circles and calculate the value. It will become 16. Third value, shift the sequence again and then overlap. This should remain same, X. This, then overlap the value X with H2 minus K. The resulting value is 14, and then last value again shift one step forward and then overlap the values, overlap the circles and find the values 16. So this is the circular convolution, in circular fashion. We will move in circular fashion, forward or reverse. Reverse only once when we fold the signal, otherwise we will move forward. Okay. Now what is zero padding? Zero padding is to add zeros in a sequence to make length of two sequences equal, because in circular convolution we notice that both the sequence, because it is to overlap two circles, though both the sequence should have the same value, otherwise it will not be symmetrical. So to perform a circular convolution, we should add zeros. To add zeros in a sequence to make length of two sequences equal, and it is why it is used, because between two values x and h, linear convolution between two values is same as that of after zero padding x and h, and we do the circular convolution of these two sequences, both are same. Then question is why it is so easy to do linear convolution instead, and why we do zero pad and then do circular convolution? Because calculation using discrete Fourier transform DFT is simple, fast, and implementable in practical scenario. That's why we use this terminology. Okay, so we'll check that. First we have sequence 1 2 3 1 2 2 1 1 2 3, two sequences are there. Suppose its length is 4, its length is 3, convolution length should come L plus m minus 1 by the formula. It is 6. So when we do the linear convolution, it results 1 4 9 11 8 3. Okay, and when we do the linear convolution using this method means after padding 0 and then doing the circular convolution, both are equivalent. So when we do the linear convolution using DFT method, we add zeros. Suppose we know that linear convolution length is 6, so to make the sequence of length 6, we must have to add 2 zeros here and 3 zeros here to make the length n equal to 6, which came from L plus m minus 1 equal to 6. So we will add 3 and 2 0 and then do the linear circular convolution as the method, and we will have the same result. We have the same 1 4 9 11 8 3. Okay, so same result can be achieved by zero padding and then doing the circular convolution method, which is much easier to implement and faster also. Second also case is that because in DFT we prefer value of n in the 2 raised to power something, 2 raised to power 2, 2 raised to power 3, that is 4-point DFT, 8-point DFT, 16-point DFT, and so on. So if we find this case, then n should be equal to 8, because nearest value of n equal to 6 is n equal to 8, which is obviously larger than n equal to 6, should be larger than. So n equal to 4 will not suit the value, n equal to 4 is less than 6. So n equal to 8 will suit the value. So we have the 8-point DFT suppose, and we check the value that after doing 8-point DFT, doing the circular convolution, means 8-point means we have to add 4 zeros here and 5 0 here, and doing the circular convolution, now we have again the 8 samples. 8-point DFT means 8 samples, and you can see that only 6 samples are non-zero, which are the same result, and 2 samples are discarded. So we can find out that whether we have to take n equal to 8, then we will only choose the first 6 sample and discard later 2. But doing this method is again the faster because of designing factors. 2 raised to power n is much easier to design instead of any value in between 6 or 7. Okay, so instead of, if we have 7 here, then we will use 8. If we have 12 here, then we will use actually 16, because around if n equal to 12, then we use the next 2 raised to power number, which is 16. Okay. Now what will happen if we do not do the zero padding? That is effect of zero padding. Let us perform circular convolution without zero padding. Suppose xn is a sequence 1 2 2 1 same sequence, hn is sequence 1 2 3 0 sequence, and the circular convolution of these two sequences having n equal to 4 will result 9 7 9 11. But you can see that this circular convolution is not the linear convolution of actual sequence. If we do the linear convolution, the result is not the same. Result will be 1 4 9 11 8 3 and 0 0 0 0 not here. It is the linear convolution. Okay, and if we zero pad the sequence in the last example, if we zero pad the sequence, then we have the result. Zero pad the sequence when we have the result 1 4 9 this one. Okay, if we zero pad the results, then we have the result 1 4 9 11 8 3 0 0. That is 8 points. Okay. So there are two results, after zero padding and without zero padding. Now what is the conclusion of this? Why without zero padding sequence will become different? Because if we do not do zero padding, then it will lead to aliasing. So zero padding is necessary to avoid aliasing effect in linear filtering. What is aliasing? Aliasing means overlapping. see 14911 and then 8300. This sequence can be break into four parts, four elements each, 14911, 8300, and check that every first part is added with fifth part, second part added with sixth part, and third part added with seventh part, and eighth sample or value added with eighth, fourth added with eight. Okay, every value is added with every fourth value. Okay, so it becomes 1 plus 8 9, 4 plus 3 7, 9 plus 0 9, 11 plus 0, and this is the sequence without zero padding. So this is the effect of zero padding, and without zero padding we will lead to aliasing of values. Aliasing is y0 plus y4, 1 plus 8 equal to 9, y1 plus y, 4 plus 3 equal to 7. So that is why zero padding is very much necessary. Without it, we will lead to aliasing effect, and our filtering action will not be the same as that of linear filtering action. Thank you very much for watching.